Welcome. In this unit, we will discuss facility location and layout analyses. We will start our discussion off with facility location analysis and then talk about facility layout analysis. The following course objectives are the focus of this video and corresponding unit, which includes applying production planning and control concepts and techniques to structured problems in order to derive meaningful solutions. More specifically, this video will discuss different types of facility location analyses as well as different types of facility layout analyses. Facility location analysis is determining where to put a manufacturing facility with the sole intent to optimize material flow by making transportation more efficient. With increasing globalization, supply chains are becoming increasingly complex. This leads to more complicated location decisions, and thus we are in need of several tools and methods to locate our facilities in the most efficient locations as possible. Keep in mind that the facility location is one of the most important decisions a firm makes. The reason why facility location analysis is one of the most important decisions a firm makes is because it is made infrequently and should be considered a long-term decision. Once this decision is made, it is difficult to change and greatly affects both fixed and variable costs of the organization. Many organizations make the mistake of making a facility location decision only based on cost constraints. However, it would be advantageous for organizations to focus on a myriad of different key success factors, especially when making a facility location decision for a strategic competitive priority other than cost. There are several attributes that may be taken into account, including access to high quality and specialized labor, an environment that encourages investment and local rivalry, which is similar to clustering, to promote innovation and access to markets, an environment that has access to sophisticated local markets, and local presence of related and supporting industries. When making a global location decision, as opposed to a domestic location decision, other factors need to be considered, including the overall political environment, including national, state, and local government attitudes toward private and intellectual property, worker attitudes towards turnover, unions and absenteeism, punctuality, legal, and ethical issues. Other issues to consider when making global location decisions include potential for new markets, labor talent, attitudes and productivity, availability of supplies, communication, energy infrastructure, currency, and trade barriers. Two location analyses, which we will discuss in this unit, include the factor rating method as well as the center of gravity method. The benefits of the factor rating method is it takes into account more critical success factors than just cost when making a facility location analysis. The benefit of the center of gravity method is it is an unbiased quantitative method that minimizes the transportation costs and takes into account not only location, but also the amount of material transferred in a given time period. Now, we will switch from our discussion of the facility location analyses to facility layout analysis. Facility layout analysis is the process of determining the type of layout strategy for your organization in order to improve efficiency of operations. There are two types of layout strategies which we will discuss: process-oriented and product-oriented. In process-oriented layout, our goal is to minimize material flow for each product. In the product-oriented layout, our goal is to equalize the task times at each workstation. The process and product strategies differ in terms of both their volume and variety. By volume, we are referring to the amount of products manufactured on any given day or during any given time period, whereas variety refers to the amount of customization that can be performed during the manufacturing process. As seen here, process has a high variety and low volume, whereas the product layout strategy has very high volume but low variety. There are a variety of factors that one must consider before they choose which facility layout. These include competitive priorities and core competencies. what sort of material handling equipment you have, as well as capacity and space requirements. Environment and aesthetics to improve productivity, morale, and customer satisfaction, as well as how information sharing occurs among the departments in your facility and the cost of moving between various work areas are also things considered. Each of these factors may greatly impact how your facility is structured. For example, in a process-oriented layout, you are producing small numbers of products that can be customized to accommodate a variety of different consumer needs. The resources are general purpose. You usually have more labor-intensive facilities due to the flexibility processing rates being slower. You also have higher handling costs and higher space requirements. In the product layout, you produce a large number of products on any given day, and resources are specialized. Facilities tend to be more capital-intensive, with less flexibility in comparison to process-oriented layout. Processing rates tend to be faster with lower handling costs and lower space requirements. There are 3 steps required in designing process layouts. First, we need to gather information in terms of the space that is needed versus the space that is available. Second, based on this information, managers need to develop block plans. You do this by developing a from-to matrix regarding trips between departments. You then use trial and error or decision support tools to develop a layout of the departments in order to minimize travel as much as possible. Third and finally, you develop a detailed layout from the block layout where you consider exact sizes, shapes of departments, and work centers, including aisles and stairways. You can then use computer-aided design or 3D models where you create drawings of the facility itself. In terms of designing product layouts, we use assembly line balancing. This is a technique where we group tasks into workstations so that each workstation has the same amount of work. This maximizes efficiency and minimizes inventory problems. There are 6 steps involved in assembly line balancing. First, we map our process by identifying all tasks as well as their immediate predecessors. Second, we calculate cycle time, which is the activity that takes the longest period of time. Third, we determine the output rate. Remember, we are only as fast as our slowest activity, which is our cycle time. Fourth, we determine the theoretical minimum number of workstations needed. Fifth, we start balancing the assembly line by determining ways in which we can combine activities into the theoretical minimum number of stations in order to get the amount of work per station as equal as possible. Sixth and lastly, we compute the efficiency. Congratulations, you have finished this video. Continue on in the lesson to learn more about facility location and layout analysis.